semester. I'm eager to see this anyway. About Xpath, which is a terrible name for how to get around XML, which is a terrible name. But we'll let Leo tell us all about these things.
All right, so welcome. Can people hear me okay? Okay, so in that case, I will leave the mask on. So I'm going to talk about navigating documents and trees with Xpath. Well, for one thing, documents and trees aren't really different things from the point of view of Xpath and of XML. So I'll start with a little bit of background about XML, since you need to know what XML is to understand Xpath, and you need to know about the structure of XML documents. And then a little bit of history, very brief, and some of the basic syntax of Xpath. And that's going to be a simplification of the syntax of Xpath to a great extent, and about what these things mean, how to take an Xpath query and figure out what it's looking for, or how to write one. And then I'll give several examples with a demo, live demo, so you can see Xpath or an XML document, and then what exactly some Xpath expressions are pointing out, and then a little bit of stuff if you're interested in more about Xpath. And I will say, since I'm the only speaker, this might go a little bit over 30 minutes, but it won't be a full hour, so I will not be keeping you for that long. All right, so a little bit about background. XML is the Extensible Markup Language. It's a language for, well, originally for representing text with markup in it. That's why it's called a markup language. Where markup is annotations or tags that mark part of the document as having some particular meaning or some particular structure, or even some particular way it should be displayed. I'll show an example of an XML document, well, actually two examples. So you can see it has a kind of human-readable syntax. And although it was originally for making text documents and marking up text documents, very quickly, and really before it even became an official standard, people realized that it could also be used for representing arbitrary hierarchical data, as long as it's something that you can reasonably encode in text. There are ways to, for example, put images into XML documents, but that's a little bit beyond what I'm going to talk about today. Now, I say the human-readable syntax, but that syntax isn't going to be the focus or even all that important for what I'm talking about. I'll show a couple of examples of XML documents, but Xpath really focuses on the data model of XML, on that tree structure of documents. So a little bit of history. XML was introduced by the World Wide Web Consortium, the W3C, who also used to maintain the HTML standards. They maintained the Xpath standard, several other things. They're no longer in charge of HTML. That got transferred over to a more industry-oriented group within the past decade. Not that long ago, but more than just a couple of years ago. Both HTML and XML are based on another language called SGML, the Standard Generalized Markup Language, which is a lot more complicated than either of them. Xpath is actually a subset, or in the terms they use, an application of SGML, but I'm not going to be looking at more complicated stuff about SGML. In fact, HTML and XML share the same object model, the document object model that describes what trees look like, what kind of things can be in them, and so on. That's important because XML isn't as popular as it used to be. When I started working with Xpath over 15 years ago, or close to 15 years ago anyway, XML was very, very commonly used for data interchange on the web. It still is to some extent, but a lot of what it used to be used for, especially with this arbitrarily structured hierarchical data, has been taken over a little bit by JSON, which is kind of a syntax with curly brackets and so on. It's a lot more concise, but maybe a little bit less descriptive in some ways. But it still is very popular. But because HTML and XML share the same object model, everything that I'm going to do with XML, and I'll show you querying XML with Xpath, can also be used with HTML. So a browser can use Xpath to, or programs that are running in a browser can use Xpath to select particular parts of a web page, not just an XML document. Okay, so a little bit about what XML documents look like or how they're structured, and we'll get to an example in just a moment. XML documents, as I mentioned, are trees. And as we know, trees contain nodes. These are the things that may or may not have children. A tree has a single root node, and so on. There are three important types of nodes, or important for today's purposes, types of nodes in XML. There are some other ones that I'm just going to completely ignore, but Xpath does work with them as well. So there's text. This goes back to the original use of HTML and then XML for encoding text with markup. So text here is just a sequence of characters with no annotation in it. But then we can also have those annotations, which are elements. So an element in XML looks like that syntax you see there. You have a opening tag in angle brackets. If you've looked at the source of a web page, you've probably seen that kind of thing. Then there's some content inside it, and then a closing tag marking the end of the element. And elements can have key value pairs called attributes, a list of them. I guess I say list, but according to the Xpath object model, at least, they're not really ordered. Although when you write out the document in text form, of course, you have to give some order to it. But the order isn't considered semantically important. And then they also have content. So this is really what defines the tree structure of an XML document. Each element has content that's a sequence of child nodes. Those are the children in this tree. Elements can have as children other elements, or they can have text nodes, as well as some of the other kinds of things that I'm skipping over. Text nodes do not have children. They're always the leaves of the XML tree. And then there's one more node, which is often ignored, but is kind of important for the semantics of Xpath, at least, called the document node. That represents the document as a whole. That's never really quite written out in dried out XML. We'll see that in the next slide. And again, there are a few other things. XML can have comments, and Xpath processors can deal with those comments. Look at them, remove them, and well, things using Xpath can remove them, and new ones, and so on. Processing instructions aren't as commonly used. If you've ever written PHP, and you've seen the angle bracket question mark PHP, that's an example of a processing instruction. And then there are a few other minor things, namespaces, CData, and so on. I'm not going to get into it all. So here is an XML document. So this whole thing is a document. The things in orange are, well, the things in orange are really tags, but they represent the elements. So we have an element called books that extends from the second line here to the very last line. And everything inside that is considered to be part of the element, or the content of that element. The element itself is, well, we'll see what that looks like in tree form in just a minute. There's a book element. It has an attribute year equals 1969 is an attribute there. So the key is here, the value is 1969. Keys are always names, identifiers. Some extra characters are allowed beyond what most programming languages allow, but still it's not arbitrary text. And the values are more or less arbitrary text in quotes. If you want to represent certain kinds of special characters that have to be encoded, but that's not really important for what we're doing here. By the time you're running Xpath on something, it's been loaded into memory, all those things have been decoded already. The text nodes are the things that are implied. So those are just plain text. And in fact, we'll see when we start doing some example queries that you can take an Xpath or an XML document and only look at the text. In a case like this, it might not make sense. It wouldn't necessarily make sense to just see the name of the book followed by ID and followed by the name of the person. These tags are needed to give it, or these elements are needed to give it semantics. But in a document that's actually, or in an actual text document, something that's representing some text that has had markup added to it, the text by itself, with all of the elements removed, all of the text just flattened out into one single sequence of characters, often will make sense. So you can take an HTML document, remove all the tags, and at least potentially make sense of some of the text. Maybe not all of it, depending on how your web page is structured. So the purple thing up here, that's not really the document node, but you can kind of think of it as representing the document text. That's, well, it's a processing instruction to some extent, but Xpath typically won't see that. This is instructions to whatever is parsing the XML, telling it that this is XML, this version of XML, and it has this particular character encoding. But you can think of that as representing the document. So the document contains everything after it. Everything after it is governed by that XML specification at the top. So we can write it out this way. This is the text form of XML. This is usually, if you're writing it by hand, this is usually what you would do. In fact, I typed this in by hand, added some syntax highlighting. But from the point of view of something like Xpath or from the point of view of a JavaScript program running in a web browser, instead, this is what it is. This is a representation of the document object model, or some important salient features of the document object model. So you have a document node at the top that has one element as its only child. Processing nodes and comments can also appear as children, but there can't be text directly under the document. There can't be more than one element. So here you can see pretty much everything other than that initial XML declaration. Everything here is inside that books element. So that is that child node of the document. And then inside that element we have, in this case, just one more element. I'll have a more complicated example when we get to the demos. That was the book. And then inside the book we have other elements, tag, language, author, which are, by the way, in a particular order. So the sequence matters. And then the title has text inside it, which I abbreviated here. The language has text inside it, and so on. And you can see with author, there's an example of an element that has both text and another element inside it. So that's really all I wanted to show as far as XML goes. This is only scratching the surface, but XML isn't the point of this talk, but you do at least have to understand how a document like this is laid out to be able to understand how to even watch for traverses, let alone how you can do so with Xpath. All right, so this is an XML document. So then moving on to Xpath. Xpath is a language, not the only one, but a pretty popular one for querying XML documents, and as I mentioned before, also HTML, since they share the same tree model, according to their hierarchical structure. So rather than just saying, find me an author, you might say, find me the author of a book whose title is such and such. So by specifying how to traverse down the tree, find the things you want, decide whether you want to keep them, and so on. So Xpath has been around for a pretty long time. It's only about a year younger than XML, or at least the official standard is only about a year younger than XML's official standard. So that's Xpath 1.0. Xpath has had several revisions since then, the most recent being 3.1, but I am going to focus on Xpath 1.0, so that version from 20 years ago. In large part because out of the box, most browsers don't support Xpath 2.0 or 3.0, at least not in full. They support usually some superset of Xpath 1.0 that is more or less a subset of 2.0, for example, possibly with some 3.1 things added in. There are implementations of later versions of Xpath. You can find JavaScript libraries to do that, for example. jQuery has support, at least for Xpath 2.0, but that's not built into the browser. There's actual JavaScript code there to do the parsing of the XPath and traversing the tree appropriately and so on. Whereas the XPath that's built into the browser, you can call it from JavaScript, but it might be implemented potentially in a different language. So I've been calling XPath a language. It's a declarative query language. It is a programming language, at least a lot more than something like XML is. XML is just representing data. Xpath is actually representing not necessarily how to do things, but what things you want to do to the text. But it is not Turing complete. You can call functions, but you can't define functions. You are stuck with the ones that are built into your Xpath engine, or the ones that are defined in the Xpath standard. And there aren't many of them, and they're pretty simple. There's no way to do arbitrary loops or recursion or anything like that, which is a lot like SQL, or at least basic SQL. If you don't have things like stored procedures and so on, with an SQL query, you also can't do arbitrary recursion, at least in standard SQL. And these queries, there are different data types Xpath supports, but the queries generally, not always, but the ones we're interested in at least, return a node set, which is just a set of nodes in the document. We'll see how you can specify those in a little bit. Those are unordered, except it turns out the document already has an order built into it, so you can apply the document order to these node sets and put them in a particular, or in a consistent order if you want, but that's not necessarily part of the semantic of Xpath, except in a few special places. And there are also strings, numbers, and booleans that are much less commonly used, although we'll see a few examples of them, particularly when it comes to credit in Xpath. So a query in Xpath, we'll see an example of that in just a minute, but a query is always executed in a context. Typically, if you're issuing a query, if you're writing a program that's searching for something in a document, that context is going to be the document as a whole. But because you can define the semantics of that Xpath recursively, when you're looking at subparts of a query, when you're looking at the predicates or the location steps that we talked about, the context becomes important because later or more deeply nested part of the queries are executed in the context that you got from earlier parts of the query. So the most basic kind of Xpath expression is a location path, which is just a sequence of steps that tell you how to go through the document from one set of nodes, initially just the context node, to another set of nodes, and from there to another set of nodes, and so on, until finally you arrive at the set of nodes that is your answer. Those steps have, and I'll show an example on the next slide, have three components. An axis, which is telling you how to navigate. Am I going down the tree? Am I going up the tree? Am I going from sibling to sibling? A node test, which says, well, okay, of the things that are my children, or are my ancestors, or are my siblings, which ones do I actually care about? Do I want the things with a particular name? Do I want the nodes of a particular type, like all of the text nodes, for example? And then predicates, which can refine that further, which can say, okay, the node test has selected some nodes, but I only want the ones for which this logical expression or these several logical expressions are true. Okay, so with some basic examples, and then I'll show a example of actually walking through a document to pull something out of it. These location steps these location paths are sequences of location steps separated by slashes. And usually, when you're writing a full Xpath expression, you write that as an absolute location path beginning with a slash. So this is pretty similar so far to Unix, navigating Unix directly. You have your root directory, which is labeled with a slash, and then you have subdirectories of that. And if you want to specify something in a really deeply nested location, then you list all of the paths from the root to get there. But if you're executing in the context of a specific node, you might have a relative path that doesn't start at the root. In this case, doesn't begin with a slash. So as an example, this line, /books, /descendant, surname, /text parentheses, shows not all of the things Xpath can do, but some of the basic things. So this is a location path with 3 steps. The first step says, well, it starts with a slash, first of all, before we even get to the first step, which says we start at the root of the document, at that document node. And then we look for a child named books. If we don't list an axis, which is written as something : if we don't list one, the default is child. So we're looking for children of the root node that are named books. Now, if you remember, there's only one child of the root node. So I could have written that a different way, but at least this way, if I write it like this, and I run it on the wrong kind of XML document, one that isn't a list of books at all, it won't return anything, because it won't accidentally select the root node that just happens to be in the same location. Then the second step here has both, or specifies both the axis and the node test. So our axis here is descendants. I'm looking for all descendants of that books node that I already selected. Well, not all of the descendants, though, only the ones named surname. And then the third also doesn't have an axis listed, meaning the axis is child. So children of that surname. And now instead of just a name, I'm giving the other kind of node test I could have, which is a node type. I'm saying I want the children of that surname node or those surname nodes that are text nodes. So in this case, well, we'll see an example of what something like or what that query pulls up in just a minute. There are some abbreviations. There's a letter missing here. I apologize. In shorthand, that should be dot, a single period, just like in Unix is shorthand for the current location. Self is one of the axes. It means just like the same place you were already at. Node parentheses is a node test saying, I don't care, just give me any node, or give me all of the nodes that you get from all of that axis. And there's also dot, which means the parent. There is also a syntax with double slashes that's a shorthand for going to descendants, but it's specified in a little bit of a non-obvious way. It's not that books / surname. That isn't the same as books / descendant : surname, which is a little bit weird. Instead, it's well, we'll get to that in a little bit, but remember that that's not exactly the same as the first thing. When I get to the examples and the demos, we'll see one particular place where that matters. But in particular, that last example here really has 4 location steps. Books, then the one that's kind of hidden between the 2 slashes, the invisible one that is descendant yourself, : node. Then a surname child of that, and then a text child of that. Okay, so here's an example of how you might evaluate that, how you might evaluate that expression on the document we saw before. So to start out, this is an absolute expression. So we start with, or an absolute path expression. So we start at the root of the document, at that document node. So I have labeled in yellow here, what is our current context? Where are we starting from? Then we go to the next axis, or the next step, which is books, which has that implicit child axis. You could also write this as child : books. And that goes to the children of that document node that are named books. Then descendant : surname goes through all of the descendants of that books node. So not the books node itself, but anything beneath it. And then the node test surname selects the ones whose name is surname. So just this node.
Is case insensitive?
The names and elements are not. So unfortunately, this would not actually match the way I'm showing it because PowerPoint insisted on capitalizing my header. So yes, imagine all that stuff in the first line is in lowercase. Also imagine that word surname over there in lowercase. So we go to the surname node, and then finally, again, there is a implicit axis of child, so children. So the answer to the last step was surname. That becomes the context for the next step. And then we go to children of any of those context nodes. There's just one. And then only the children that are text nodes. So we get finally with. We could have expressed this query in a number of different ways. If we were just caring about this document, of course, there are many different ways we can select just that single node. But there would even be different ways to write this for a query on any document that has the same general kind of structure. So I mentioned the axes just to give a list of some of the important ones. Well, you can imagine we're working with trees, so you've got a child, parent. I mentioned earlier that you can have a dot representing the self-axis. So you can also use that to maybe apply multiple node tests to the same node, although it's not common that you would need to do that. You can also specify descendants or ancestors. So just the transitive, the strict transitive closure of child and parent respectively, or the non-strict versions, descendant or self, ancestor or self. It's just descendant as well as myself, and parent as well as myself. So like a union of those two axes. And then because XML has, or the XML document model is ordered, the children of a given node, of a given element have a specific order, you can also ask about not siblings, but about following siblings and preceding siblings. So I can go to nodes that have the same parent as me, but that are later in that parent's list of children. And then there's also following and preceding, which uses something called the document order. And document order is just a pre-order depth first reversal of the entire tree. So parents precede their children. A child or a node will precede all of its siblings, and so on. And then finally, attribute. So going back to this, I didn't mention it before, but the book node here, the third one down, has an attribute. Here equals 1969. So you can specify that you care about the attribute itself and not the element as a whole by using the attribute axis, which has an abbreviation. And then those node tests can be a name, which will refer to the name of an element. Text nodes don't have names. The document might have a name, but we usually don't care about that in Xpath. And some of those other special node types I mentioned, like processing instructions, can have names. Namespaces can have names, and so on. I can say I don't really care which things I'm looking at. I'm giving star. Star means any element, not any node, but usually any element. unless if the access is attribute, star instead means any attribute, because attributes and elements are not the same thing. But in most cases, with almost all of the axes, star means the element. Star means any element. And then if you want to refer to other kinds of nodes, you can use what I showed you before, the type of the node followed by parentheses. So text in parentheses is the only one that's going to really be important to us today, but there are also things like comment and processing instruction and so on. And then finally, node in parentheses. That's also a node type test, but every node matches that. So you might think star is a wild card, saying I want everything, but really the real wild card is node parentheses. Star is specifically only elements, which seems a little bit weird that it wasn't the other way around. Element parentheses for elements and star for nodes. But in some cases, it might make it a little easier or at least shorter to write the kinds of queries you're likely to write. In other cases, though, it's just confusing. You can also have, and I'll show another example of going through something like this on the next slide. You can also have predicates at the end of your location set. So what I've showed you so far haven't had predicates, but a predicate, well, you have your axis, which tells you which direction to go, and the node test, which lets you very coarsely say which of those things you care about, just based on the name or the type of node. But predicates let you get into a little more detail about which ones you care about. So after you've figured out what the nodes, what the axis and node test selects, what your potential set of answers is, you then apply the predicates to both. And predicates can have some pretty complicated, well, not complicated compared to most programming languages, but complicated compared to path expressions or to location paths. It can have some complicated expressions, including relational operators, logical operators, and or not, arithmetic, calls to built-in function, and so on. And of course, arithmetic doesn't make sense unless you have some way to get a number. Well, many of the built-in functions will return numbers. So you can ask for the position within the set of numbers, or the count of elements returned by a particular query, and so on. And then, so that expression is evaluated, and in Xpath, an expression can evaluate to a string, a number, a boolean, or a node. If it evaluates to a number, then that's treated as a position within the set of nodes that you selected. Well, node sets are unordered. This is where the document order comes in. That position is the position if you sort them according to document order. So I could, for example, select the second book element in the entire document by doing the query like this. / descendant, : book. This locates all of the book elements. And then I'm going to filter that down by selecting only the second of those. The second query shows it's not as, or it's not that they're not applied separately. They're applied sequentially, or at least you can think of it that way. That is this second query, / descendant, : book, predicate 2, predicate 1, returns exactly the same thing as the one above it. Because after the square bracket 2, we've selected a single node, the second one in the list of all the book nodes. And then out of that single node, I'm selecting the first one in that list, which is the same thing. Which can be a little bit confusing. If you see something in square brackets, you have to remember that it applies after all previous square brackets, and that has implications for how you evaluate Xpath. Otherwise, if it's not a number, so that's kind of a special case. Everything else, any other kind of query, or any other kind of expression, which can include a query, can include a location path, is evaluated. You get the result. That might be a set of nodes, it might be a boolean, it might be a string. and then that's converted into a boolean in more or less the obvious way. The empty string is false, all other strings are true. The empty node set is false, any non-empty node set is true. And usually, sometimes you will have something that's explicitly has a boolean value. So find all the books whose position is greater than 2, which would be all the book nodes after the one that we selected in the previous query. Or I could say even something more complicated like position parentheses greater than 2 and position parentheses less than 5 to find books 3 and 4. Or I could use greater than or equal to and so on. But most often, what we write inside the brackets is going to be an expression that gives me a node set, but maybe another query, for example. So I might use //book to find all the books. That's not quite the same /descendant : book, but for this query, it's close enough. It does the same thing in this query. And then in the square brackets there, I am issuing another query. Notice it doesn't start with a slash. It's relative, not absolute. So it's evaluated in the context of the book. So it's looking for a child of the book called author, and then a child of that called pseudonym. And that gives me some set of nodes. That might be an empty set. In the document we saw, it is an empty set. There are no pseudonym nodes at all. Or no pseudonym elements at all. So this evaluates to the empty node set, which is false, which means that particular node won't be selected, that particular book. And then that's evaluated on every single book. Or at least notionally, it's evaluated on every single book. Turns out that there are computational complexity problems that arise from doing it that way. Okay, so here's an example of evaluating something that's a little more complicated. It has a predicate. It has the star as remember, that's the node test. That means I want an element. So again, it starts with a slash. So this is a absolute path. Descendant : star means all of the descendants of that node that are elements. So we select all of the elements. That's our current context. And then we apply the predicate to filter that set down. So for each of the elements, I find a text node child of that element. And then, so for title, I find the one that says the left hand of darkness. For language, I find the one called EN. For author, I find the one Ursula K. And for surname, I find the one with Will. For book, I didn't find any. So book does not have any children that are text nodes. Books does not have any children that are text nodes. So that whole path step selected these nodes. We started out with all of the elements, but then we filtered it down to only include the ones that have children that are text nodes. And then we can ask for, from the context of all of these, find all of the element children. And there's only one. Author has a child called surname. That's an element. But none of the other ones have children that are elements. So that lets me select this. So one way to read this is find all the nodes in the document, or find all the elements in a document that have a child that's a text node. Or, sorry, have a sibling that's a text node. That's not the only way to do that query. There are other ways you could write this. I could explicitly, rather than using these predicates, I could say, go to all of the text nodes, find their siblings that are elements. And that would find the same set of nodes here. Okay, so so those were just a couple of simple examples where I had time to make these tree diagrams and color them in. But let's do a little bit of live work now. I'm going to start with an expanded version of that XML document and issue various queries. We'll see what they return and why, and a couple of kind of surprising cases. website called xpather.com. You can do this in the JavaScript console of your browser. And I might show that once, just so you can see how ugly it is and why you don't necessarily want to do that if you're playing around or trying to learn things. It does give you a lot more information. The information can be kind of hard to parse. There's sometimes an overload of information there. And then this link will take us to that website preloaded with the document. So here we go. Let me first go to a version of that XML document I have. You can see the browser started to render it with as a tree, as a text representation, something like this, and then it decided to just show me all the text without any formatting. Because I haven't told the browser how to do formatting of these kinds of XML documents. The browser knows how to format HTML because there are style sheets and so on associated with that. And even without the style sheets, HTML specifies a presentation of many of its kinds of elements, but XML does not. That said, I can open up the developer console with F12 and maybe go to the inspector and then see a tree structure of the document. You can also see a couple of things I omitted, like I didn't really talk about white space. Those are just text nodes. But when you're processing an XML document, there are ways to tell for many processors, there are ways to tell it white space isn't important or white space is important. So rather than just look there, I can go to the console and I can issue an Xpath query, and I can do this from a JavaScript program as well, with $X, and then in parentheses, in some kind of quotes, JavaScript can use double quotes or single quotes for strings. I can specify something like maybe /author. And that gives me, as the answer, an array of nodes. And if I kind of look hard enough or know what I'm looking for, I can find what else is inside that node and so on. But it's a little bit of a pain to expand all of these things and scroll past all the details we don't necessarily care about. So let's go. So this is Xpath. On the left, I've got my XML document. It automatically applies syntax highlighting, and then I can type in an Xpath query. So, for example, /books. You can see on the left, it highlighted what was selected. Now remember, there might be multiple things selected, so you can't just tell from the highlights exactly what the node set is, because you can have queries that select both an element and one of the sentences, for example. Over on the right, you can see the list of results. There's only one element in the node set, or one member of the node set. And if I hover over it, it will highlight where that is in the original document. Right now, it's showing it as plain text, so all of the XML syntax stripped out. But I can go to Node View and see it with all of the markups in place. Okay, so that's the simplest possible query. Let's pull up a few more examples. So maybe I want to select the first author of the first book. Well, the first book only happens to have one author, but that's a detail of this particular document. So I can do something like this. Go to the books node, go to the book children of that, select only the first one, then go to the author children of that and select only the first one. So that gives me this node. Or I can have a query that returns multiple results. So the surname of the first author of each book. So I'm not specifying a particular book. This is any book child of the books node. Go to its author, go to their author children, select the first one in each context. So here's one. This is the first author of, or the surname of the first author of the first book, the surname of the first author of the second book, and the surname of the first author of the third book. You can have queries that happen not to match anything, so there is no book child of the root node of the document, so no elements were found. We've already seen things like this. I can select all the books. It looks like almost everything is highlighted, but I can hover over particular ones to see the different results. So, let me skip over a few of those. You might think, well, I showed /books/book a square bracket 1, so you might do something like this, and it happens to give you what you expect. It's a second book in the document, but that's not actually what the query means. As an example of why not, how about this query? You would be tempted to read this as find the author, find the first one. But you have, for this, you have to remember the definition of double slash is go to, starting from the context node, the root, go to the descendants or self, any descendant or self node. So that selects all of the nodes in the document. Then, for each of those, find a child named author or the children named author, and find the first one. So this is the first author child of any element. So it's giving me, in this case, the first author of each book. As another way to write that, as I mentioned, this is what it should look like. And then if I really want just the first author in the entire list, then I have to explicitly write this is the descendant axis. And now this is the result set would be before we do the predicate, all of the author nodes in the context of the root node, and then I select the first of those, rather than selecting the first author node in each of the contexts of the previous step. Okay, I'm running low on time, so let me give you just one or two more examples showing some of the other things you can do with numeric queries, for example. So I'm going to all the books. Then I'm selecting the ones that have a year attribute. At is short for the attribute axis. And that year attribute is greater than 2,000. When I do a comparison like this, it's converted to the string here is converted to a number. Let me go to one that works and then another one that doesn't work. So I could look for the book that has an author whose surname is Stein. But this is not really, it doesn't work for the reason you would expect. And as an example of that, this is a query that actually works in, Xpath 1.0. It doesn't work in Xpath 2.0 because the way functions work when you give them lists of things has been changed. Contains in later versions of Xpath, including the kind of intermediate hybrid version that my browser is using, requires the first argument to be a single thing, or 0 things or 1 thing, not a list of things. So this will not find the books that have an author whose surname is CO, or at least it won't find Corman here, because it's actually wanting to compare Corman and Lyserson and Rivest and Stein all to CO, but you can't compare them all to CO at once. In Xpath 1, you actually could. So we have to do that in a little more complicated way. So I could do something like this. So rather than asking does the surname contain this, or do the surnames contain this, instead I use a predicate to say, okay, for each surname, does it, remember dot is the current node, contain st. And now that is selecting a book that has an author whose surname contains the letters capital S, lowercase t. Stein was one of the authors of CLRX. Okay, so those were just a few examples we went through pretty quickly. Just as a little bit more, so what else should you look at? Well, there are some tutorials out there on the web. The Mozilla Developer Network documentation on Xpath is pretty good. W3 schools, a little bit less good, but it's a lot simpler, so it's quicker to go through. Once you've gone through that, you can go to the Mozilla documentation for a little more information. If you were really curious, or if you're implementing your own Xpath query processor, then you'll need to read the technical specifications, which is, like most technical specifications, not the easiest thing in the world to read. It goes very much into the exact syntax, written in a way to make it completely unambiguous, but also makes it a little harder to understand for humans. And then if you want to go even further in the direction of completely unambiguous but hard to understand for humans, there is a publication of the W3 consortium on the semantics of Xquery, which is a related language that uses Xpath, and of Xpath 2.0. I don't think W3C ever released an official formal semantics of Xpath 1.0. There is some stuff out there in the literature. And then just one more thing. I mentioned computational complexity can be a problem. The way I've shown you for evaluating these things, you have to start at the first node, find all the nodes that might match the next step, then for each of those, find all the nodes that might match the next step, and so on. If you do the naive recursive implementation of that, then it can take exponential time. There are pretty easy ways around that in the simplest cases. So one problem would be if you have alternating, I'm looking for any descendant. Okay, now I'm looking for any ancestor of that, any descendant of that, any ancestor of that. I'm going up and down the tree several times, each time selecting, or each time I take the descendant axis, selecting potentially the entire tree. There are ways to deal with that, but it's even more complicated to deal with sequences of nested predicates, because to evaluate one predicate, I have to evaluate the predicate inside of that at each of the context nodes. Well, it turns out you don't actually have to do it that way. In this paper, Pickler found a way to do these evaluations, even for most complicated expressions, in polynomial time. It's something like, for full Xpath, it's something like on the order of the size of the document squared times the size of the expression to the fourth. But they also identified some useful subsets of Xpath that could be evaluated in time, linear on the size of the document and the size of the expression. Now, of course, those are multiplied together, so if you have a huge document and a huge expression, that still might be a long time, but it's still linear on each of those individual components. And the way they do that, you can read the paper for more details, when you're evaluating predicates, instead of going from the outside in, which is how I described it, you can actually go from the inside out and see, for this most deeply nested predicate, which nodes would that evaluate to true on? And then which nodes, when I evaluate this predicate, would find one of those nodes that evaluated to true, and so on. Okay, so that's all. I guess I ran pretty close to an hour, actually, so thank you for your time, and happy to answer any questions you might have about Xpath, XML, etc.
Questions? Yeah.
So, again, to give a context, could you, I know the answer, but
where I was using it, I'll mention that many other W3 standards use Xpath. So XSLT, XML style sheet transformations, uses Xpath to identify which things are transforming, and so on. I, in particular, got interested in Xpath when I was researching access control, fine-grained access control for XML documents, where you're saying not just who can modify this document, but which parts of the document can they modify in which way. And one of the ways that's done in the academic literature on the topic is by giving XPath expressions that identify a selection of nodes and then saying if these particular users have permission to insert a node that would match this predicate or to remove a node that matches, or not predicate, this XPath expression and so on. So that's where I got interested. I only looked there at a pretty small subset of XPath, something called core XPath, which is one of those subsets where back in 2007, 2008 or so, people had already developed the formal semantics. The formal semantics I showed you for XPath 2.0 only came out in, I think, 2010, 2011 or so.
I've also used Xpath in converting information about utterances in endangered languages to format them so you can see them nicely. I use Xpath to split off the various parts of the utterance, which was presented to me in XML, and then I'm able to derive from that something which I can show. And that's a subject of a completely different talk.
Yeah, and I guess I should mention one more thing there. I said that JSON is kind of supplanting XML for a lot of uses. As of 3.0 or so, Xpath actually does have support for querying JSON rather than XML, but it's a little bit weird, so I didn't want to get into it too much today.
All right, well, let me advertise that there will be more keeping current seminars in the future, but only if people will volunteer to present them. I've only got one more volunteer in, I think, 2 weeks. So next week, it's completely open. Volunteer to talk about something. And I'll see you at the next time. Thank you.